Okay, good morning. Today, for Algebra 2, I'm going to be covering Chapter 11-1 on permutations and combinations. So before I get to the lesson, there's a couple of formulas we need to go over. The first one is, this is called factorial. When I have that exclamation point there, like n exclamation point, that means n factorial. And factorial means you multiply all the numbers, including that number and below, together. So, for example, if I had 4 factorial, that would be 4 and all the numbers less than 4, multiply those together. Stopping at 1. So 4 times 3 times 2 times 1. 6 factorial, 6 exclamation point, is 6 times 5 times 4 times 3 times 2 times 1. All right, you punch those numbers together, put them in your calculator, and you get an answer. Permutations. This is the formula for permutations, and the big thing that's important about permutations is that order matters. All right. There's a formula down here for combinations, which we'll get to in a second also, and that's where order doesn't matter. All right. Those are the two big things that you want to keep in mind. You want to remember permutations is where order matters, and combinations is where order doesn't matter. Okay, so they have this formula. There'll be two numbers next to the P, one before it, one after it. Okay, that'll be the N and the R. Remember, the N, the one in the front, is always bigger. It just always is. So if you're stuck on which one goes where, the bigger one always goes in the front, the smaller one goes in the back. And then we'll plug in the numbers and do some factorial, and I'll show you how to do that in a little bit. But that's the formula for the permutations. Here's the formula for the combinations, which is the same thing with the bigger number always in the front, smaller on the right. And that'll determine the N and the R. This one has an extra R factorial in there. And like I said, I'll show you how to use these in a few minutes. But combinations is where order doesn't matter. Permutations is where it does. All right, so that's some of the big stuff that we'll be getting to. So there's also this thing called the fundamental counting principle. And the best example I got here is if I told you that we had 3 shirts and you had 2 pair of pants, and I asked you how many outfits you had, you would sit there and think about it for a minute and say, I'd have 6. And you'd get that by multiplying the 3 times the 2, all right? Also, you could have done one of these trees, a number tree kind of thing where you got 3 pair of pants, and for each pair of pants you get a couple of limbs coming off for each shirt, which gives you 6 different possibilities if you go and count down all those rows there. Okay, so that's the other way you might have done it. Okay, but that's the fundamental counting principle. Okay, so you might see some of those problems as well. All right, next. Let's see, number 1. So this has to do with the fundamental counting principle. A Maryland license plate has how many possibilities? And apparently with this problem, or with Maryland license plates, they have 3 letters in the front followed by 3 numbers in the back. So what you want to do is figure out all the possibilities. So how many, in case you've forgotten, there's 26 letters in the alphabet, and there's 10 digits, including 0, 0, 1, 2, all the way through 9. That's 10, okay? So if I was going to break this down for F, the first one, that's 26 possibilities, okay? And then I got the H, which gives me 26 more. I'm going to multiply all these things together at the end. And then V, that one's also a letter, so it has 26. And then I get to the numbers, okay? So there's 10 for the possibilities for the 0, 1, 2, for the 1 there. 10 possibilities for the 9, and 10 possibilities for the 4. Okay, so the last thing you do is you multiply all those numbers together, and you come up with this really big number, 17,576,000 possibilities. And that's the answer, okay? So that's an example of using that fundamental counting principle, okay? All right, next. how many ways can you form a line? Can you form a line with 6 students? Okay. Can a line be formed? Anyway, wasn't worded well. My own fault. So with this, order matters. So, this is that classic problem where you got elementary school kids and they're lining up to go to recess or something, and if teacher says get in line, and there's 6 kids. How many different ways can you have that line? And certainly that order matters there, because anybody who's remembers elementary school, it was super important to be first in the line. Which means this is going to be, you can do it one of 2 ways. You can either say it's 6 factorial, or you could do permutations 6 people, because there's 6 people getting in a line, and there's 6 possible people, and all 6 of them are getting in line, so it's 6p6. So let me do the first one first. If I was doing 6 factorial, this is the same as 6 times 5 times 4 times 3 times 2 times 1. And if you punch that into your calculator, you will get 720. Now, if I did the formula, remember that the permutations formula is NPR equals n factorial over n minus r factorial. So if I was doing it this way, and both of the numbers are 6, which makes it pretty easy. So I get, change colors here, 6 factorial over 6 minus 6 factorial. Zero factorial, I forgot to put that on there, is 1, all right? It goes against what you'd think. You'd think it would be 0, but it's actually 1, which means this is 6 factorial over 1, which is just 6, okay? All right, so that would turn out also to be 720. Either way, that's what you get for an answer, okay? Okay, so let's work a little bit with the formula here. 10p3. So I'm using this formula here, that one. So 10 factorial over 10 minus 3 factorial. Okay. Now, there's an easier way to do some of these, especially if you're, got a simple calculator. This is 7 factorial. Your calculator will get overloaded at some point, so it's kind of nice sometimes just to find this other way to do it. So 10 factorial, that's 10 multiplying all the way down to 1, right? But I don't have to go all the way down to 1. In fact, I could stop at 7 and throw the exclamation point there, and that covers the 6, the 5, the 4, the 3, the 2, and the 1, right? Now, why did I do that? Because I have a 7 factorial in the denominator, and there's this beautiful thing in math where if I have the same thing in the top and the bottom, I can cancel them out, and then I can just multiply the 10, the 9, and the 8 together. 9 times 8 is 72. 72 times 10 is 720. And you get an answer just like that without a calculator. Okay? All right. So that's the answer. Next one. Why don't you try this? I want you to try it. And remember, there is use your formula. Okay, so take a minute, hit pause, go see if you can come up with it. Okay, and here's the answer over here. If you did it correctly, you should have gotten that. Okay, number 5. Big one, bigger one. So, this one, if I plug in the numbers, 100 factorial over 100 minus 2 factorial. So this is 100 factorial over 98 factorial. So this is 100 times 99 times 98. And if you want to go all the way down to 90 to 1, feel free. I'm canceling out here at 98 factorial, which gives me 100 times 99, which means I got 99 plus 2 zeros. That's what you do when you multiply by 100, is add 2 zeros. So you get that, okay? Now, there's a lot of calculators in the world, and a lot of them could handle that, okay? Some might not. There's probably an exclamation point button on there on your calculator. In fact, a lot of them have an MP, a permutation button as well. So if you search through your calculator, you might find that as well. It could make life easier. But you might want to know some of this stuff too. I've been known to put questions on quizzes or tests where I'll overload your calculator just to see if you could break it down, something like this over here, and cancel out the 98s, for example. But anyway, yeah, calculators are a nice tool if you know how to use them. Okay, so number 6. Did I finish solving that one? Yeah, I did 9900. Okay. How many ways can 15 runners finish first, second, and third? And the driving question you're always asking yourself with this one is, does order matter? Because maybe it's permutations and maybe it's combinations. We'll cover them both. So I got two number. Order matters for this, first, second, and third, because everybody wants to come in first, right? Well, why would you come in third if you come in first? So order obviously does matter. Yes, order matters, which means we're working with permutations. We're using that formula, okay? What are the two numbers? Well, they're right there in front of you. Here's that, and there are 3, so it's 3 and 15 are my two numbers, because there's first, second, and third, all right? That's 3 numbers, that's why. Okay, so you take your formula, and it's 15 minus 3 factorial, all right? And next, I'm going to do this out. I get 15 factorial. 15 minus 3 is 12 factorial. So I got 15 times 14 times 13 times 12. And then instead of going all the way down to 1, I'm going to stop there at 12 so I can cancel out my 12s. And if I multiply 15 times 14 times 13 together, I get my answer of 2,730. Okay. All right. Good. Next one, number 7. So here's the combinations formula. Notice how similar it is to the permutations one. The only thing that's different is it has the extra R underneath it. So this was permutations. And combinations is in blue there. So they're very similar, okay? So if I'm plugging this in, 13 goes in the numerator. I use the 4 twice. Here's the R4. And then it's 13 minus 4 factorial. Okay, so I forgot the exclamation point. So this is 13. Let's do the denominator. This is 4 factorial. 13 minus 4 is 9. So I'm going to stop at 9 on the top when I get to it. 12 times 11 times 10 times 9 factorial. Now I can cancel out the 9's, right? And now what I'm left with is 13 times 12 times 11 times 10 over 4 factorial, which is 4 times 3 times 2 times 1. And if you go and punch that into your calculator now, you should get an answer of 70. Okay, that's the answer. If you multiply all that stuff out and divide, okay? This one, what is the value of 8C3? So once again, if I'm plugging these values in, 8 will be the N, 3 is the R, now I can simplify it. Let's see, denominator I got 3 and 5. 8 minus 3 is 5, so I got 8 times 7 times 6 times 5 factorial. Then I can cancel out the 5 factorials. And I got 8 times 7 times 6 all over 3 times 2 times 1. Oop, out of space. And if you do that all out, punch it into your calculator, you should get 56. Yeah, right, which makes perfect sense since I can. 3 times 2 is 6. There's a 6. This one is 8 times 7. Okay, why don't you try? C92. Here's your formula again. Okay, so hit pause and come back. Welcome back. So here's the answer number 9. You should have gotten that if you did it out correctly. Next, word problem. Choosing. So they're not going to tell you which it is. You have to figure out whether you use the C formula or the P formula. Remember, order matters for the permutations. Order doesn't matter for combinations. The question says this. You will draw winners from a total of 25 raffle tickets. First prize wins $100, second prize wins $50, third prize wins $25. How many ways can you draw 3 winning tickets? So with this one, I think it becomes pretty clear order does matter, okay, because the first number you draw is the $100 winner. The second one is going to be your $50, and third is your $25, okay? Which means I'm using the permutation formula, okay? Okay, so what are the numbers? That's the next question, right? I need the N and the R. So I got the permutation. There's 2 big numbers in this thing, the 25 and the 3, because there's 3 winners, 25 people are in it, okay? That's where the numbers come from. And it's really pretty straightforward like that, which means I got 25 factorial over 25 minus 3 factorial. Oops, I got the ordered backwards there. Okay, so that's 25 times 24 times 23 times 22 factorial. Over 22 factorial, then those cancel. And if I multiply those 3 things together, I get 13,800. And that's the answer. Okay. 11. You were trying out for a basketball team. There are 20 players trying out for 8 spots. How many teams of 8 could be made from the 20 players? So does order matter? That's the question you're asking yourself. So in this case, order doesn't matter. You know, either you make the team or you don't. All right. It's not like, you know, the first place winner gets, first person to make the team gets $100 and the second place person gets 50. So this one, order doesn't matter. Which means I'm using the C formula. Okay. Now, what are the 2 numbers? Well, they're right here in the word problem. There's 1 there's the other, okay? 20 spots, 8 players make it. That's 20C8. Remember, this bigger number always goes on the left, okay? Smaller one always goes on the right. So this is 20 factorial over 8 factorial times 20 minus 8 factorial. Okay, and you can probably punch that in your calculator. You know, hit 20 factorial over 8 factorial times 12 factorial. Please don't multiply the 8 and the 12 factorial together and get 96 factorial. That's wrong. Don't do that, okay? You need to do each one out individually. So this is clearly one you're going to need a calculator for. I mean, you could break down the 20 times 19, go all the way down to 12. But you know, your final answer is going to be 125,970 combinations. Okay, and that's it. Next one, a lot of word problems. This one, 8 students are running for student council. The student with the most votes will be president. Second most will be vice president. Third most will be secretary. How many different student councils could you have? So that same question, does order matter? The answer is yeah. Order matters. Right? Because first gives president, second is vice president. That means order matters. Which means we're using the permutation. And what are my two numbers? 8 and 3, because first, second, and third, there's president, vice president, secretary. That's 3. Those are the only 3 that matter. 4th, 5th, 6th, they didn't get any position at all, so those don't matter. So 8p3. So I got 8 factorial over 8 minus 3 factorial, which is 8 factorial over 5 factorial. So if I break down the 8, I can go times 7 times 6 times 5 factorial. Cancel these out. 8 times 7 times 6 will be my answer, which is 336. Okay. And that is it. That was my last problem for the day. Guys, have a wonderful evening, and I'll see you all soon. If you have any questions, please bring them to class. Thanks.